The HVAC School podcast is made possible by these great partners. Carrier and Carrier.com. Carrier has been a long-term sponsor of the podcast. They've made it possible very early on for us to do what we do, and they are the products that we sell day in and day out. Everything from single-stage equipment all the way up to the Green Speed Extreme, one of the most efficient products on the market today. Find out more about what Carrier has to offer and about becoming a Carrier dealer by going to Carrier.com. Don't miss HVACR's ubiquitous event. Of course, I'm talking about AHR Expo 2025 coming to our hometown, Orlando, Florida, February 10th through 12th. Explore the latest product advancements, best practices, and industry trends. Register now for free at ahrexpo.com. Copeland and the Copeland mobile app. Get full access to Copeland's online product information database on any device, any place. And try out the new Copeland AI chatbot. Cross-reference compressors and find local inventory, all on the Copeland mobile app. Refrigeration technologies at refridgetech.com, and specifically the new Viper Wet Rag Heat Shield, the revolutionary flame-resistant welding pad designed to be used either wet or dry. Find a Viper Wet Rag Heat Shield at a distributor near you or go to TrueTechTools.com and use offer code GetSchooled for a great discount at checkout.
This is the guy that complains about capacitors failing, but prays for a failed capacitor at his last call every day. Bryan Orr.
Excellent. This is the HVAC School podcast. I'm Bryan, and yeah, you know me. This is the podcast where we talk about HVAC stuff, and today we're going to talk about surge protection again. And this time we're going to talk specifically about both surge protection, but also voltage monitoring with DITEK. They have a couple products that you should be aware of and some misconceptions around surge protection for the HVAC contractor that you should be aware of. Just the basics of how to wire the things, how to talk to clients about it, that kind of thing. It's a simple podcast, but one that I think will help you feel more confident around surge protection, specifically for AC techs and service departments, that kind of thing. So here we go. Deploying surge protection in HVAC with Mike Molinari. Thanks for joining us on the HVAC School podcast, Mike.
Thanks for having me, Bryan. Appreciate it.
Yeah, so it was fun talking to you about some of the basics. Now, today, I want to focus specifically on how we apply surge protection, or specifically, as we learned last time, SPDs. What is it? Surge protective devices? Is that right?
That's correct.
Surge protective devices. Okay. How we apply that as an HVAC contractor? How can we serve our clients, do a really good job so that we're providing something that's a real value to them, but then also hopefully it helps our bottom line? To start with, though, I just want to ask it as a question. A lot of people have their doubts about surge protection and whether or not it's a strategy that we should be offering to all of our clients. Give me the pitch about why every air conditioning system out there should have some surge protection, if that is actually your stance.
It is. It's by far the most expensive appliance that you're going to purchase for your home in the vast majority of cases. And these systems becoming more intelligent. They have variable speed compressors. They have inverter boards. They're electronic systems now. And just like you wouldn't hesitate to plug your 85-inch TV into a surge protector, you shouldn't hesitate to add surge protection to the most expensive appliance in your home. It is tried and true technology. Surge protection's been around for decades upon decades. If I had anybody that had concerns about why it doesn't work, et cetera, I would ask directly, well, tell me some of your concerns and let's walk through that and see if we can ease your mind there. But I can assure you, we wouldn't have been in business for 36 years selling a product that didn't work.
And again, American-made product right here in Florida, great support. One thing, I did this last time, but just to remind everybody, I'm a fan of DITEK because of that family business that you guys focus strictly on surge protection. That is the focus of the business. And they make everything from really high-end industrial type of solutions all the way down to residential. So there's a lot of confidence in the engineering and manufacturing controls, which is why I like DITEK. Let's talk a little bit about specifically how to talk to a client about it, and then we'll go into how you wire it and just making sure we're doing it all right. But for a lot of technicians, especially the ones who listen to the HVAC School podcast, they're not salespeople. They don't necessarily love talking about money with clients. How do you introduce that? How would you do it, I guess? Because you eat and breathe this stuff. How would you introduce that topic to a client that maybe has an existing system? You're there doing a maintenance. You're there changing a capacitor or whatever. How do you bring it up?
Just bring it up. That's half the battle. Truly, it is such inexpensive insurance in the grand scheme of things. A typical surge protector at a distributor is in the order of maybe $50, $60. That's what a contractor would essentially pay for it. I'm just giving you a very general number there. On a $8,000 to $16,000 system, if you do the math, it's really inexpensive. The challenge is most homeowners just don't understand that there's a product that's out there that can protect that system. So just by bringing it up, you'll have a relatively high close rate. Hey, just Mr. Customer, I noticed you don't have a surge protector. You live in an area that maybe have a lot of thunderstorms, or we have power quality issues day to day. This is something we highly recommend for all of our customers. Most people will go ahead and put that on there. I actually have a little bit of my own data, and shockingly enough, just to give you an idea how grossly underserved our industry is when it comes to surge protection. I live in a neighborhood, single-family homes in Palm Harbor, about 310 homes. And I have a 7-year-old daughter, and I've walked many of those streets with my daughter, and I've looked at everybody's air conditioning disconnect. To date, I've only counted 11 surge protectors out of 310 homes. And a lot of these systems are new. A lot of them are within the last few years. But the sheer math on that, I cannot believe how low of a number that truly is. And it's just more of a lack of education and lack of bringing up the product than homeowners just blatantly saying, no, I don't need that. So really, that is half the battle. Bring up and add value as being the expert that's standing in front of that person, because they sure are not.
All right, I'll give you some of the common objections that probably don't exist in the real world, but exist in my head. Because I'm one of those techs who's like, oh, I don't want to sell anybody anything. It's going to be... I make up excuses of what they'll probably say. What if they say, well, I already pay for the one that the utility puts on my meter base. I don't need another one, do I?
That's where we get into that analogy that we discussed in the previous episode of those barrels on the highway and capturing that let-through voltage that will happen at that meter-based surge protector and making sure you're isolating your most prized possession, especially during the months of July, August, and September in Florida where you need cooling. The last thing you want is your system down from a surge. So also, the HVAC system itself is a big cause of surges being generated on the electrical system inside the home. So surge protectors are dual functioning in the sense that they'll dissipate a surge regardless of whether it's generated from the compressor, the condensing unit, or coming in from the utility, because it is wired in parallel with that 240-volt split-phase circuit. So if there's any excess energy, no matter where it's generated, it's going to be safely dissipated to ground. So it's performing like a dual function there. It's protecting the HVAC system, but it's also grabbing any surges that were generated from it.
So Florida or the Southeast, where we know we have a lot of strikes, and again, we'll talk more about that. It's not like if lightning were to strike your actual air conditioner, it's not going to help with that. But we have a lot of lightning. And so in this market, it makes a lot of sense. But what about markets where there maybe isn't as much lightning? Does that diminish the need for it? Or how would you, maybe somebody who's in California or Ohio or something like that, who says, well, we don't have as much of a lightning problem, so we don't need that here?
That's when I usually ask them, have you ever experienced a brownout or a power outage or a rolling blackout? Most folks will say yes. That's grid-based power quality issues. And the aging infrastructure in this country just can't handle the demand that we're placing upon it. So the more demand, by the way of EV chargers being installed in everyone's homes, grid-tied solar arrays, et cetera, is stressing the already antiquated system that much more. So those power quality issues, the byproduct of that are transient voltages. The challenge there is you can't really see a transient voltage. You can see a lightning strike, can't see a transient voltage. So those small power quality issues are chipping away at the lifespan of your sensitive electronic equipment. Till one day it quits a year after it was installed and someone's questioning, why did this thing only last a year? Most likely it was basically exposed to a vast array of power quality issues, transient voltages, under voltages, etc.
So now let's get into some specifics on, we're convinced, client wants it. We got to think about where to put this thing. So we get this surge protection device, and where should we most likely install this? And then how should we install it?
If you're talking like a unitary system and you're going to have a disconnect outside feeding a condensing unit, that's pretty much the ideal place to go with the surge protector. So It's a 3/4 inch MPT, so you're going to knock out a 3/4 inch, and then you're going to wire in parallel to either the line or the load side of that disconnect. There really is no preference. I've seen a lot of debate online and comments on YouTube videos about the line and the load side. There's really no bearing on it as far as the surge protector is concerned. What you do want to be cognizant of is you don't want to violate any type of double tap or double lug. And that is a highly contested subject right now because it seems like it's a jurisdiction by jurisdiction type of issue. You'll have electrical inspectors that have checked that off for 4 decades, and you'll have newer folks that were sent out from a homeowner's insurance company nitpicking everything and saying, absolutely not, you can't land that wire under a lug. That's not rated for 2 wires. And there is credibility there because NEC, where it is, it's in section 110.14, I believe. And that lists off if the lug itself or the terminal is not explicitly rated for multiple wires, you can't put multiple wires under that lug. And that's where you would create a little pigtail, which we do have in our wiring diagram in our product. Just a little 4 or 5 inch wire coming out of the load terminal. And then you're going to connect your load wires with the surge protector wires right under a Wago or wire nut, whatever your approved method is there in your jurisdiction.
I'm a big fan of Wagos. I've only recently been introduced to them, but I'm finding excuses to use them all the time, even in cases where it probably doesn't make sense just because I love them so much. I just love those little levers. They're so much fun. Anyway, that's a side note. I want to take a second and talk to you about Copeland and the Copeland mobile app. And they've been recently developing, it's been kind of hush-hush. It wasn't allowed to tell you until now, but it's pretty cool. They've been developing a new AI chatbot that takes HVACR service, information, and product education to the next level. Copeland Mobile already has a great database of online product information that allows you to troubleshoot and diagnose easily, as well as find replacement products. The new AI chatbot makes it even easier to look up product information and replacements. It's also available in several languages other than English, including Spanish, so those of you who prefer to read in Spanish or work with Spanish-speaking customers can reap all the benefits. The chatbot works like a search engine. Just ask it a relevant question, of course, and it'll bring up several results that could come in handy, from oil recommendations to replacement parts to specs. The chatbot can even compare compressors within the Copeland product line and compare Copeland's compressors to their competitors. If you can't find an answer, there's an option for live chat with a representative available 24 hours a day on weekdays. You can track all of your projects in-app with job site commissioning, making it easier than ever before to stay organized. Once you know which parts are right for your client's application, you can save them to your wish list in the app, and the Copeland mobile app can show you where to purchase them in your area. Being able to save parts in a wish list type fashion comes in pretty darn handy. Just log all the parts you'll need and save time you would have spent making trips to the supply house or multiple phone calls. Copeland is leading the charge with the Copeland mobile app, product education, and support, and this AI chatbot is making its just-in-time education model even better. Find out more about the Copeland mobile app, its recent updates, and its trajectory. I like saying trajectory like that. Trajectory at hvacrschool.com/Copeland-mobile. That's hvacrschool.com/Copeland-mobile. What about the ground side? So we talked about this a little bit last time. You want to keep everything as short as you possibly can. How do you go about connecting ground in the best possible way?
Usually with the ground, that's a little more lenient. So like on a neutral bus in a panel, you definitely cannot have 2 wires under 1 lug. The grounding bus, it's a little more leniency there, I think, to where if you have 2 ground wires landed under a single lug, I've never really heard of anybody getting called out for that. You being a licensed electrical contractor in the state of Florida, you could probably comment more on that. I've never had anybody call and tell me that say, hey, I landed my surge ground under a grounding bus and had 2 wires and somebody didn't like that. But if you have an extra terminal, great. But typically inside a disconnect, there's only going to be 2 lugs for the ground. So you might have to share it with one of them. If you get somebody that's got an issue with it, you'd have to essentially add an additional ground bus in there and link them together. So you have a little multi-position ground bus tied into the ground of the disconnect and go that route just to avoid any double lugging.
This is going to be very much jurisdictional. I'm not afraid to say that I have never heard of a situation where you've got a double lugging infraction on a ground. It's all about the quality of the connection, though, so you do want to ensure. What I was suggesting in the last one, too, is just make sure that all of your, like visual inspection, tug on the wires at the condenser, at the disconnect, all that. Make sure that it is connected all the way back. That's fairly important at that point, that you do have a good, solid ground connection. One of the things I was going to ask you, though, is because there's a lot of cases, even in our market, where you'll have condensers that will be tied into a panel. So maybe even it's a meter base and it's got the panel beneath and you don't have a disconnect because it's so close. In cases like that, what would you suggest? Would you just connect it on the side of the panel, or how would you do that?
Yeah, it's going to depend on the breaker brand. Some of the breaker brands will allow a double tap. The Square D, the Home Line, and the QO breakers will allow 2 conductors under that terminal, so you could tie it in parallel that way. You could also do a simple pigtail as well. You come off with your load wires, you intercept that, you add Wago or a wire nut and continue that way. The ultimate goal is to intercept that circuit and keep the surge protector wires as short as possible. Regardless of where you install it, it's always going to be in parallel. It's never going to be wired in series. So you're just grabbing that circuit where you legally can. And so if you don't have a disconnect switch, you would intercept it anywhere between the load terminals of the circuit breaker and the condensing unit itself.
Pretty simple. So we've got 2 different sides to the equipment, though. We've got a condenser, we've got an air handler. What do you suggest on the air handler side or on the low voltage side of things? Do you have any thoughts about that?
Same product. We have a lot of contractors that protect both circuits. Usually, like at my house, I have a 60 amp feeding my air handler and I have a 40 amp feeding my condensing unit because I have 10 kW heat. So it's a little larger circuit draw there. So fortunately for me, my air handler is located in the attic above the garage and I have a disconnect that's feeding the air handler. Cool. I have a CM Plus right there installed on my air handler. For those that have a direct connection going into the air handler itself, I have seen a few contractors that'll just drill a 3/4 inch in the air handler and go wired in parallel with the electrical circuit that's feeding it. That's fine. You can do it back at the electrical panel via pigtail. You can do it where if you have a breaker that accepts 2 conductors, you can do it that way. You'd have an issue with that because just because it accepts 2 conductors, they need to be the same wire gauge. You have 12 gauge coming out of the surge protector, which is just going to limit you to a 20 amp circuit. So you're really never going to see that occur unless you like a mini split application that you only have a 20 amp breaker or something along that. So usually a pigtail or installed at the equipment.
Let's talk about the CoolGuard. Tell us about the story of that product and then what problem it's solving for.
Yeah, in circa about 2020, early 2020, before the world got flipped up on its end, we had a local distributor come to us and asked us if we would be willing to design and manufacture a voltage monitoring device. And the reasoning for that was they were carrying a product at the time that is still out there. It's a big name, but it had a few shortcomings. One of the shortcomings with it was not only price, but the fact that you had to calibrate it to a nominal voltage. And in some instances, the calibration portion took maybe an hour or 2 sometimes. And if you're selling a $400 or $600 product and you're spending 2 hours of labor calibrating it, all your profit's going out the window. So this distributor came to us with a punch list of items of what they'd like to see, a specific cost, and challenged us to create a product. So we turned it over to our talented engineering team, and the fruits of that labor after about 1 year and 3 months of trial and error and a lot of R&D is the CoolGuard. And the really neat thing about designing and manufacturing product under one roof is we didn't just do it in a bubble, send it overseas and say, here you go. We had a lot of input from a few local contractors. What do you like about the product? What don't you like about the product? We were able to test it on various systems. So we got it right. Is the CoolGuard perfect for every application? No, it's perfect for the vast majority of applications. And it's my opinion in 2024 that we've moved beyond standard surge protection, basic surge protectors as the gold standard for protecting air conditioning systems. And the reason why I say that is everything is becoming high SEER, everything's electronically controlled. You're seeing more inverter boards, more variable speed, ECMs, et cetera, et cetera. For the very small price difference between a standard surge protector and a voltage monitor that has surge protection in it, considering a $12,000, $13,000, $14,000, $15,000 system cost, it's a no-brainer to me to go right to the CoolGuard. And we'll talk in depth, obviously, about what problems it solves, but it's a hard case to argue to say, no, I don't want the voltage monitor. I'll just go with the regular surge protector. If it's conveyed correctly, you're not going to get very many people choosing the latter.
So I think any of us who have worked in commercial are familiar with voltage monitoring and how important that is, especially when you get voltage imbalance between phases or you get phase loss. None of us really thought about even the possibility of needing voltage monitoring in residential. So talk about why that's emerged and become more important.
Your standard surge protectors won't do anything until they see about 150 volts or more on line to ground. So in a 122/40 split phase, we have 120 nominal to ground on each leg and 240 between them. So a typical MOV that's in a surge protector is rated for about 150. You're already at 150 volts before that device is even going to turn on. Electronically controlled systems, inverter boards, do not like over voltages, and they sure don't like under voltages. Surge protectors do absolutely nothing for an under voltage. So you can have an incoming line to ground voltage of 100. A surge protector is going to sit there and do absolutely nothing for you, but that could chew up the lifespan of your inverter boards, things that are built into your mini splits, your inverter-driven systems, etc. When you deviate too far out of that nominal voltage range for too long, that's where you begin to have problems. And I think 15, 20, 30 years ago with just single stage compressors, it wasn't that much of an issue. But now with everything being electronically controlled, I haven't talked to many HVAC contractors at all that said, we don't have power quality issues on our newer equipment. Somebody has a story or multiple stories where they've continued to lose equipment. A home is on the end of a grid in a rural area and they just have unstable power, not necessarily a bunch of lightning, but they have unstable power and the equipment just suffers the damage. And that's where good voltage monitoring comes into play.
I just want to take a second to talk about my friends over at AHR Expo. They really are great people who run that event. I've gotten to know Nicole pretty well over the years. They just run a great show. They do a really good job with it. And it's huge. It's a lot of people, thousands and thousands and thousands of people. A lot of people ask, like, well, how does AHR compare to your event? Like, they're not even close to being the same thing. I mean, our event is a very small event, a bunch of nerds getting together, learning and swapping ideas. AHR is huge. Huge. It's going to be huge. We have the podcast pavilion, all the manufacturers, people from all around the world gather, and you get to see new technology, hands-on demonstrations, all this kind of stuff. AHR is just a completely different animal, and it really is an amazing experience. It helps you realize how huge this industry is and how many people are excited about it. And it is in Orlando this year. It's the same general time as our symposium. So February 10th through 12th, AHR Expo. The website is ahrexpo.com. Go get your tickets for free at ahrexpo.com. I will be there a bunch, but a lot of other people will be there. Just all the movers and shakers in our industry, all the interesting folk who do podcasts and YouTube channels and all that stuff. They'll all be there, as well as a lot of great educators and all those manufacturers that build the products that we work with every day, whether it's tools, equipment, you name it, it'll be there. AHR Expo 2025, Orlando, my hometown. Be there or be sad. I don't want you to be sad if you're not there, but I do want you to be there, so just be there. ahrexpo.com. We've seen in our market, Central Florida, and I've talked to a lot of other people who've seen the same, and this isn't necessarily true of every single brand of equipment, but we had a particular series of equipment that was super, super sensitive to any steady state overvoltage. And what we're seeing is more and more utilities are providing both steady state overvoltage, but then also you get issues and you have brownout power conditions. And back to what you were saying, where we do have more issues with inverter-driven equipment failing in both of those cases. But especially from my experience, especially the steady state overvoltage, we've had a lot of issues. But even back to before that existed, there was a time where we had a brownout in Groveland, Florida, that took out like hundreds of contactors throughout a subdivision because of low voltage. Because what happens when you decrease the voltage on the primary also decreases the voltage on the secondary of your transformer. And the contactor started chattering, and then it just flipped the points upside down, blew them all over the place. And I was going house to house replacing contactors at one point. So it's always been an issue, but I think what is the biggest issue has maybe changed a little bit. And I think market to market, this will vary. But to your point, talking about CoolGuard, so CoolGuard does also provide the surge protection as well?
Yeah, it has the same TP MOVs that we use in the surge protector installed at the board level on the KG2. What's really cool about that is you eliminate all of the lead length issues because the CoolGuard is wired in series with the circuit between the condensing unit and the disconnect. The TP MOVs themselves are soldered onto the board. So if you want the quickest reacting surge protector, you'd want the MOVs to be right there at the board level without any lead length. But first and foremost, it's a voltage monitor with surge protection. It's not a surge protector that happens to do voltage monitoring. And a couple of the punch list items that we settled on with the CoolGuard, number one was the pre-programmed voltage range. So the challenge with some of these other devices on the market is you have to set a voltage threshold. The average HVAC technician bringing a product out to a customer's site, when they go to, well, what voltage range do I set it to? What am I going to reference? Let's look at AHRI. What we did was we looked at the 110 standard for utilization range B and utilization range A. And we settled on a line to ground voltage window of 104 to 130. And we get a lot of questions like, well, Mike, why 130? Voltage range B goes up to about 127.2, about there. They might say, why aren't you cutting voltage at 127.1? Here's why. The KG2 is actually measuring every cycle of the sine wave. So it's 60 hertz is 60 cycles, 60 times a second. Every single cycle is measured independently for each phase. If either phase goes low or high for one cycle, it's game over. We're cutting the power for either 30 seconds or 3 minutes, depending on how you calibrate the unit and what you set it for. When you choose to do it that fast, you have to allow for a little bit of wiggle room, because the utility, like Duke Energy's here. I think you guys are you guys Duke over there or
Duke and Seco are our two.
Duke and Seco, okay. Voltage range A, essentially the utility, the range that they can give you at your home on each phase to ground is 114 to 126. That's considered good. If I was clamping the voltage at 127 and doing it incredibly fast, do you know how many nuisance calls we would be getting? Then you'd have a homeowner trying to fight with Duke saying, my power's too high. They're going to say, no, it's within range. So where we landed on with that is by choosing that speed, we allowed ourselves to increase the voltage window by a few volts to allow for a little bit of wiggle room, but catch anything before it causes any damage. So this was a lot of trial and error, with what number we should use. So the advantage of a pre-programmed voltage window, it does not need to be calibrated in the field for 240 or 208, which is really cool. So if you're in a commercial environment and you're pulling 2 hots off of a 3-phase 208 volt Y panel, you don't have to do anything with the unit. It auto calibrates for that, because we took the path to measure each phase independently. The other devices on the market are only measuring line to line. So in an open neutral condition, you have 240 between your hots. Your line to ground voltages are completely different. The CoolGuard would actually detect an open neutral condition where the others would not. We felt that was a more accurate way and a faster way to protect equipment, so we did it like that. The other big thing was, I'm not going to throw out names, I'll just call it for what it is. The 2 other major voltage monitors out there are big gray boxes with caution labels on them that are sitting on the side of somebody's home. The average homeowner is not going to go into those boxes. They're just not. The geeks like us, the folks that are probably listening to this podcast, we will. The average homeowner will not. The CoolGuard displays its fault conditions via LEDs right through the cover. So it's a NEMA 4X polycarbonate. We chose that to account for coastal homes where salt air chews up NEMA 3R steel. So we decided to go with 4X polycarbonate to keep it completely corrosion proof. And that cover is staring at you. If you're walking the dog or you're mowing the lawn, you always see the voltage condition via a set of green and red LEDs. Green solid on both phases is good. If that unit is ever in a fault, either over, under, on either phase, it's going to be blinking red. Somebody will be able to tell without getting out a screwdriver or opening up any electrical enclosures that there is a fault. And that has been huge for folks because it's much more aesthetically pleasing on the side of your home than just this big gray clunky box.
Yeah, for sure. And I did not understand that phase to ground thing. That's very interesting. If I would have paid attention, I would have known that. But
that's why I'm here.
That does make a big difference because I've seen some things. And again, this is caveat for everybody listening. I do not know for a fact whether this is the case. This is completely circumstantial. But there have been cases, and this comes into play when you have a high leg delta system with ductless, where we've connected to the high leg and boards kept failing. Even though, because you're using 2 legs, the voltage is within range. When you have a high leg to ground, if you still are going to be more likely to have two ground shorts because now you have higher voltage pressure to ground. And so that's an interesting thing because you see crazy things when you get neutral loss in a house or in any structure. And depending on what's running inside the structure, you'll get these big spikes on one side. And you would say, well, on a 240 volt appliance doesn't make any difference. But I think it does because you still have higher phase to ground voltages present than you would have had otherwise in certain places. Again, depending on the situation, obviously. But we're talking about circuit boards. We're talking about highly complicated devices nowadays. And my theory still is that when you have higher phase to ground, you still have an increased likelihood of shorts or damage to controls. So
the CoolGuard would catch that, whereas a device that's only measuring line to line essentially wouldn't.
Interesting. We probably went over a lot of people's heads there, but it's a fun conversation and definitely does help establish the value. What about your clients? When you're talking to your clients, often homeowners will say something like, oh, so this is going to protect me against lightning. How do you have that conversation so that you are being honest, but still not maybe downplaying the value?
You throw out the stats. Less than 2% of equipment damage comes from direct lightning strikes. That's the statistics. And as we had alluded to in the previous episode, the vast majority of surges are coming in from the utility. They're coming in from nearby lightning strikes, which are jumping on the utility transmission lines. And they're coming from surges that are generated from within your own home. The refrigerator compressor cycling on and off, the vacuum cleaner, the microwave, things of that nature. The way to explain it to folks, because you can't really see this stuff, is I say, have you ever been sitting inside your house and you hear the air conditioner click on and the lights dim a little bit? Yeah, I've seen that before. That's exactly what we're talking about. That's an inductive load. Essentially what we're describing there, that's something you can see. And that does fall under the bundle of power quality issues. So everybody thinks lightning because it is so dramatic and grandiose, but it's not the most common cause of surge damage. And if you just throw out and have that conversation and understand the statistics, they'll be more likely to believe, oh, okay, there are a whole lot of other causes of why I should invest in this product.
Yeah, and ultimately just not wanting to have things fail and break in their house. Yeah.
It's cheap insurance.
Yeah, cheap insurance. Yeah, for sure. Great. So for people who are interested in learning more about surge, maybe interested in learning about DITEK, there's probably a lot of contractors who are going to be listening to this. Who are like, well, I already use XYZ product. There's no reason for me to change, whatever. Tell them how to get a hold of you and maybe some of the reasons why they might want to consider switching to DITEK.
There are a lot of surge protectors there that have a big name on them, but the vast majority of those are private labeled through companies that private label and get them offshore. Going back to the whole thing, there are companies out there that sell surge protectors. DITEK is a surge protection company. That is tried and true. And if you factor in the amount of quality checkpoints and pride that goes into the manufacturing of the product. And for those of you that local in the Florida area, if you ever want to come by and take a factory tour, we're open for that. And it's really cool to see the advanced equipment back there that actually goes into making these products. So if you're really interested in automation and manufacturing facilities, we would be one to visit. Also the support. When and if you do have a problem, I would place our support above anybody else's. We truly do go above and beyond for our customers, just from the simple fact that you get a live person when you call this 800 number, that goes miles. It's very price competitive. You'll see a few brands on there. You're not going to see DITEK that's like triple the cost of what's already existing there. If you're happy to support a product that's made in the USA versus one that's not, all things being equal, we'd love to have you as a customer. And we're not in the business of losing customers. Once we get you, you're probably going to have you for life.
So yeah, DITEKsurgeprotection.com, is that the best site to go to learn more about the products?
Yeah, and we've got a YouTube channel that's got some interesting information on it. It's essentially DITEK, D-I-T-E-K, if you just search for it on YouTube. If you want to link up with us on Instagram or Facebook or LinkedIn, we always post content, not just HVAC, but all others, low voltage security, fire alarm, industrial electrical infrastructure, everything. I mean, we are a one-stop shop for surge protection. So if you are in the trade but happen to be multifaceted in the sense you're an electrical contractor that has a low voltage division, you would definitely want to be engaged with us because we can help you with all of those needs in those other verticals.
Great. And the product that I'm going to encourage you all to just take a look at is the DTK-KG2. That's CoolGuard, and CoolGuard is spelled with a K. So that's the CoolGuard 2. DTK-KG2 is a very interesting product, and that's the one that we were just talking about, that not only does the surge protection, but really fundamentally is a voltage monitoring device for those brownout and over voltage conditions as well. So awesome. Well, thank you so much again, Mike. It's been enjoyable as always, and I'm sure we'll do this more.
Thank you, Bryan. This was awesome.
Again, big thanks to Mike for coming on. Very helpful, very useful to cover topics that actually can be misapplied. We talk about like indoor air quality a lot. Surge protection sometimes falls in the same category just because a lot of people maybe oversell it. But again, to what Mike was saying, as long as you understand what it really won't do, and that has to do with direct strikes, it's cheap insurance. It's not like it doesn't work. It does work, but it also helps to have that belt and suspenders type of an approach. So anyway, good conversation. Appreciate Mike, appreciate DITEK and their American manufacturing, like I've mentioned before. So yeah, I just burned 2,000 calories. I forgot a pizza in the oven. Thanks for listening. We'll talk to you next time on the HVAC School Podcast.
Thanks for listening to the HVAC School Podcast. You can find more great HVACR education material and subscribe to our short daily tech tips by going to hvacrschool.com. If you enjoy the podcast, would you mind hopping on iTunes or the podcast app and leave us a review? We would really appreciate it. See you next week on the HVAC School Podcast.